Good morning to all. I am Professor Pravin. Today is my second lecture for technical and preparation for GATE 2021. Sometime this lecture you can use it for preparation of IS and IAS exam also, civil services exam also. So without wasting time, we are going to speak about the subject. Today's subject is structural analysis. So the contents covering in structural analysis are basic concepts, statically determinate beams and frames, statically determinate truss, influence line diagram, statically indeterminate beams and frame, slope deflection method, moment distribution method, arch, cable structure, matrix analysis, structural dynamics, and additional examples. Here I am covering all the numericals also, theory part also, but today's lecture I am covering only basic concept. So as this lecture is for preparation of GATE, so I am going somewhat speedily. If you are unable to understand this lecture concept during this lecture, you can attend the audio video lectures of these subjects whatever I am uploading later on. So I am focused mainly on GATE 2021 preparation. So this will be the structural analysis. Last time I have uploaded a video on project management. Now I am uploading video on structural analysis. Now basic concept. So these are the books: RC Hibbeler 9th edition, 6th edition, then class notes and workbook, and previous year GATE question papers. So their analysis also I am explaining in one video, but later on, because I have started the GATE preparation for different subjects. First I will cover that 7 sections of civil engineering, and then we'll go for the analysis of previous years GATE question paper from year 1997 to 2020. So here basic concept. Now in basic concept, structural engineering. What is meant by structure? Structure is any arrangement of members that can transfer load acting upon it to the support safely can be termed as structure. When structure means it is any arrangement which can transfer their load safely. And in structural engineering, there are two different portfolios, that is analysis part and design part. As far as analysis part is concerned, the subject names are SOM and SA, that is strength of material and structural analysis. And as far as design part is concerned, RCC design, PSC, that is pre-stressed concrete design, and steel design. So as far as in analysis part, we'll have to manage, we have to learn the things regarding equilibrium, compatibility, and energy. And as far as design fields are concerned, we need to study safety, serviceability, durability, economy, and aesthetics. Now meaning of structural analysis. So here meaning of structural analysis is, so firstly we'll take the arrow which is visible now. So here meaning of structural analysis is support reaction we need to calculate in analysis part. Analysis part, there is structural analysis, SA. In analysis we are having two subjects, SA and SOM. In SA what we'll do, we'll calculate support reaction. By using support reaction we can calculate bending moment diagram and shear force diagram. And as far as SOM is concerned, strength of material is concerned, we are related with the deflection and rotation, stress concept, and strain concept. Stress is internal resistive force, and strain, as you know, there is a elongation factor. Then here is the comparison between idealization of structure, real structure, and idealized structure. As far as idealized structure is concerned, the joint here is a roller's joint, and here in real structure joint is like this. Then next is the planar structure and 3D structure. If there are two axes are only sufficient to describe or define the geometry and loading of structure, then that structure is called as the planar structure or 2D structure. And if three axes are used required to define geometry and loading of structure, then that structure is called as the 3D structure. Then here I have given the example: 2D structure, x direction, y direction, and this is 3D, x, y, z axis. Then sign convention. So this will be positive for, as far as x axis is concerned, this direction will be positive, y axis above upward direction is positive. As far as z axis is concerned, x bar into y bar, that is y, x, and z. Now rotation. As far as rotations are required for movements, so clockwise positive, forces along axis, movement clockwise positive. So this will be the sign convention. This will be the sign convention. As far as shear force is concerned, bending moment is concerned. As I am going very speedily, so if you are unable to understand this concept, you just attend the lecture, whatever I am taking, audio video lecture taking for this subject, for each topic separately and with giving time, and there I am giving teaching all the concept, basic concept. Here I am going very speedily because I think you should know something this, because in first year, second year, third year you have learned this. As far as fourth year concerned or GATE preparation is concerned, only GATE 2021 is on February 2021, so only 3-4 months are remaining. So our study should be in this fashion only. Then types of supports. So support means any arrangement that can restrict movement of any point of structure is called as a support. Support means where the movement can be restricted. So there are different supports. Here I have prepared chart, that is movement restricted, representation, reaction and remarks. So XY rotation. So this is the fixed support. Fixed support has 3 reaction, that is the horizontal, vertical as well as movement. As far as pin or hinge support, there are 2 reaction only in XY direction. So horizontal reaction and vertical reaction. As far as guided roller support, like this, only 2 reaction, that is vertical force and 1 movement. And here guided roller reaction in this fashion. Then here X rotation. In this column I have written where this support allows movement and where this support doesn't allow movement. So here X rotation will be there. So there will be this X component of force and movement component. As far as the roller supports are concerned, so this will be 1 reaction, horizontal reaction. If support is like this, that is the Y, movement is free and X is restricted, then there will be this Y component. Then inclined roller support, there will be this inclined reaction. So you can that is resolve this force into 2. So you will get the 2 reactions. So as far as inclined roller support is concerned, 2 reactions are there. There is, as far as roller support is concerned, there is only 1 reaction, but this is, as this is inclined support, it is, this angle is, this support is, this reaction is inclined. So there are 2 reactions. If we resolve it, as you know, resolution of force, composition of force, you have studied in the strength of material or engineering mechanics. Now note, inclined roller support and hinge support both don't provide any movement in X and Y direction, but we get the 1 reaction for inclined roller and 2 reaction for hinge supports. So this is a roller hinge support and this is the inclined roller support. So this will be Rx Ry and this will be R, and this is Rx Ry, this will be R. So 2 unknowns are either Rx and Ry or R and theta. That is there are 2 different systems. So I not remember. So here then unknown is only R because beta is known. Then types of structural members, then members and their unknown forces. If members are axial member, then the unknown force will be only 1 unknown component. If beams and frames are the members of structure, then unknown forces are 3, that is the axial tension or compression, shear and moment. So this will be the, if cables are there, there are only 1 unknown, that is the axial tension, because its thickness is negligible. As far as cables are concerned, their thickness is negligible. We are considering unit thickness. Then equilibrium and static equilibrium. Then equilibrium, if net force, that is force and moment, net force means force and moment acting on a body is 0 in all directions, then body is in equilibrium. For example, body is in space, vehicle moving with constant speed, they are the example of equilibrium. So for 3D, summation fx is equal to 0, summation fy is equal to 0, summation fz is equal to 0, summation mx is equal to 0, summation my is equal to 0 and summation mz is equal to 0. If in 3 dimensional body is in equilibrium, pure equilibrium, it is called a pure equilibrium. And as far as 2D concerned, xy plane, summation fx is equal to 0, summation fy is equal to 0, and moment at z is equal to 0. Then static equilibrium. Static equilibrium, it net force acting on body is 0 and body is in rest or static state. Then only body can be classified under the static equilibrium condition. That is example, buildings, bridges. Means if net force acting on body is 0 and body is in rest or static state, body should be in rest and acting force will be 0, correct? So that will be static equilibrium. Then compatibility, the continuity or good fit of material or member or components while being deformed under loading is called compatibility of structure. So compatibility of member, so in this fashion, if this support is fixed support, this cantilever beam, the load P is acting here, so this will be what we can say, this beam will bend in line this, like this fashion, bending moment will be like this. So this will be the deflection or deformation, you say deflection, and its value will be calculated PL cube by 3EI. P is load, L is length, E is modulus of elasticity, and I is moment of inertia. Then compatibility is not maintained due to fracture in member. So compatibility is not maintained because of sudden change in slope at B. So here compatibility is not maintained due to fracture. Here fracture happens here in this. So compatibility is not maintained. Here compatibility is not maintained because of sudden change in slope at B. So what is compatibility? Compatibility means this is continuity or good fit of material or member or component while being deformed under loading. Means member does not crack. If it is crack, then compatibility is not maintained. If member doesn't crack while deforming, so it will be compatibility. Now sudden change in slope A, then smooth curve. If sudden change, the bending moment diagram will be like this. If smooth curve is there, there will be a compatibility. Now compatibility of support. So as we have seen the compatibility of members, here we will see the compatibility of support. So compatibility is not maintained because of non-zero slope at fixed support. If fixed support, non-zero slope. If slope is 0, then there will be compatibility. So here compatibility is not maintained because of non-zero vertical deflection at C. Then compatibility of joint. Compatibility is not maintained because of change in angle between members at rigid joint C. So rigid joint C, correct? Then here compatibility is not maintained because all three members are not intact at O. At O, all three members 1, 2, 3, these three members are not intact. There will be a crack. Then free body diagram. So free body diagram, what is meant by free body diagram? It is the graphical representation of any body. It is the graphical representation of body with all the forces acting on it. So internal, external, whatever forces acting on body, if we show it by line diagram, then it is called as the free body diagram. Whenever we do analysis of statically determinate beam or indeterminate beam or any structure, any figure, then that time before starting the analysis, first step is to draw free body diagram. If we draw the free body diagram, then we will know what are the different types of forces acting on the body, and then it is easy for us to do the analysis. Now statically determinate structure. For analysis of statically determinate structure, there are different steps to solve the problem. First step, make body free from all loads and reactions. Apply all loads and support reaction. Apply all internal forces at cut section to satisfy condition of equilibrium. Already I have posted one special lecture, audio video lecture on this statically, how to determine or how to analyze statically determined structure, that is the frames or beams or anything. So you can refer that also. I am giving here link in description box link of that audio video. Then apply all internal forces at cut section to satisfy condition of equilibrium. Then note, preferably way of representation of force at cut section are in like this fashion, and this is preferable. So this way you can refer at cut section. Whenever we do as analysis of statically determinate beam, there are two methods. One is the section method, method of joints, and method of section. So that time we need to method of section, we need to find cut the member. So here there we need to show the representation of forces movements at cut section. So this way you should show. Then statically indeterminate structure. As far as statically indeterminate, so what is the difference statically determinate and indeterminate structure? The structures which are statically determinate are there are unknowns equal to number of reactions. So whatever equilibrium constant or equilibrium reactions are there, so there will be same number of unknowns will be there. Known component, known reactions and unknown will be the same. As far as indeterminate structure, the as we know, equilibrium equations of equilibrium are only three: summation fx is equal to 0, summation fy is equal to 0, and summation moment is equal to 0. But as far as statically indeterminate structures are concerned, there are more than 3 unknowns. So that's why these are statically indeterminate, and there are different methods to solve these problems. So step 1, make body free from all the loads and reaction. Then apply all external loads, all possible support reaction, because support reactions are not known. Because second step is always calculate support reaction without considering load. Whatever load acting on the external load acting on this frame or body, you just remove that load or don't consider that load, and then find out the support reaction. If the supports are hinged, then supports are maybe roller supports, maybe or pinned support, or maybe fixed support. Based on that support, earlier we have studied the number of reactions for different support. So based on that you calculate the number of support reaction. Then apply all possible internal forces at cut section, because member forces are not known to us. So apply all possible forces at cut section. Take the cut section and draw the free body diagram of that cut section, and then here, so we are taking cut section here, so draw the free body diagram at this cut section. So this part, this side and this side, cut section, free body diagram for this section and free body diagram for this section. If we take cut like this, and if we take cut like this, show this only, and find out the reactions. Then static determinacy. Static determinacy. So what is meant by static determinacy? If available equations from conditions of equilibrium are not sufficient to analyze the structure completely, then such type of structure is called statically indeterminate structure. So same thing I have told earlier. Support reactions, that is the equations of equilibrium equal to number of unknowns. Number of unknowns are equal. Then we'll go for degree of static indeterminacy. Total number of unknowns, that is internal forces and support reaction, minus total number of available equations from conditions of equilibrium is called a degree of static indeterminacy. Static indeterminacy means it is the number of total number of unknowns, that is internal forces, support reaction, minus total number of available equations of equilibrium, and their difference is called as the degree of static indeterminacy. That is the meaning. Then observation in above FBD, total number of unknowns are 10. So if you do this analysis of this, the total number of unknown 10, R1 to R10. Everything I have shown here. This is the main example given. This is the free body diagram I have drawn. Then number 10, then total number of available equations of equilibrium are static equilibrium are 9 for 3 portions, 3 into 3. So there are first portion, second portion, third portion. So each portion we are having 3 equations of equilibrium, that is summation fx is equal to 0, summation fy is equal to 0, and summation moment at that point is 0. So 3 into 3, 9. So here 9. Then conclusion from above FBD, it is clear that only one unknown R1 is required to be known to calculate all other unknowns R2 to R10. So degree of static indeterminacy is 1. In general, minimum number of unknown forces are required to be known to calculate all other unknown forces, that is a support reaction. So that will be the note in general. But here, this way you should calculate the static indeterminacy, degree of static indeterminacy. Then procedure, how to find the static indeterminacy. So first identify start joint, calculate total number of unknowns, member forces and support reaction at that joint. Then step 3, calculate total number of available equations including extra equation due to release at that joint. Then calculate step 2 and minus step 3. This is static indeterminacy at the joint. It may positive or negative. Make mark on each member meeting at that joint. Repeat step 2 to step 5 at all joints. Add up values obtained from step 4 for all joints. This is the degree of static indeterminacy. Note, free end of overhang portion should also be considered as a joint. If there is a free end of overhang portion, that should be also considered as joint. Then this will be the examples. So in examples we will see later on. Here we will see only theoretical parts only. Now effect of internal hinges. So internal hinges are, so this way, these are called as the internal hinges. It is a joint in a structure about which part of a structure may rotate. So hinge, if there is a hinge, there may be a rotation. So internal hinge, internal rotation. If structure is in equilibrium, then no part of structure is rotating about hinge. It means moment about internal hinge from either side must be 0. So here this is the problem, and this will be the support reaction. As this is fixed support, there are 3 reactions, this one and moment, and here as far as this roller support, only 1 reaction. So calculate summation fx is equal to 0, summation fy is equal to 0, find the equation summation moment at z is equal to 0, so moment at a is equal to 0. So this way you calculate R1, R2, that is R1, R2 and R3, then calculate R1, then arrangement of hinge, number of extra equations. If 2D are there, so this will be the arrangement of hinge. If 2 parts are, 2 parts are there, and there will be a hinge. If internal hinge connects 2 parts, this part 1, part 2, then there will be one unknown, one extra equation. If 3D, 3 equation. As far as 2D figure, if 2D, then will be 2, then 6, 3, 9, 1 and 3. If the support conditions are like this, as far as 2D is concerned, 3D is concerned. In general, 2D structure, no extra equation at hinge. Number of members connected through hinge are only 1. Then, so this will be the example. If axially loaded member is connected through hinge, then that does not provide any extra equation at hinge. So no extra equation. If axially loaded member is connected through hinge, axially loaded, so this is axially loaded, so no extra equation. This is not axially loaded, this is axially, so 1 extra equation. then same thing will be there. Then external and internal static indeterminacy. So already studied internal static indeterminacy. There are two types, external and internal. As far as external is concerned, for 2D structure, degree of static indeterminacy internal is equal to total number of reactions minus 3. For 3D structure, degree of static indeterminacy external, total number of reactions minus 6. If internal static degree of indeterminacy internal, that is static degree of indeterminacy total minus static degree of static indeterminacy external. So here the example. So concept of link. Link is a structural member connected through hinges at both ends. Link means link is a structural member who's having hinges at their both ends and subjected to no loading in between them. It is axially force only. No loading in between them. It has only axial force only. Then it is called as the link. So this will be the link. This will be the link between this member and this member. Then 3D structure. This will be 3D structure. Then formula for degree of static indeterminacy. Degree of static indeterminacy is equal to total number of unknowns minus total number of available equations. If 2D, as far as beams and frames are concerned, DSI is equal to 3m plus r minus into bracket 3j plus extra equations due to release. Truss DSI, that is the degree of static indeterminacy, is equal to m plus r minus 2j. M is the number of members, j is the joints, and r is the reactions. For 3D beams and frames are concerned, DSI is equal to 6m plus r minus 6j plus extra equations due to release. And as far as truss is concerned, 3D truss are concerned, DSI is equal to m plus r minus 3j. Here m is the number of members, r is the reactions, and j are the joint. Then stability of structure. Difference between movement and deformation. Difference between movement and deformation. So this will be called as deformation. This will be called as deformation, and this will be called as movement. So this will be the deformation, and this will be the, if a forward motion of any joint is there, that will be the movement, and if bending is there, that will be called as the deformation. This is bending due to this force, so that is deformation. Structure is considered as stable if there is no movement due to application of load. When we will say structure is stable, if there is no movement of structure due to application of, we have applied load but there will be no movement, then only this structure is called as the static. Otherwise it will be remain dynamic. Stability check. Step 1, calculate DSI of structure. Then step 2, if DSI is less than 0, then structure is unstable. If DSI greater than equal to 0, then structure is unstable. If, so here something I have written wrong. If DSI is less than 0, the structure is stable. If DSI is greater than 0, equal to greater than equal to 0, then structure is unstable. Structure is unstable. All reactions are parallel. All reactions are concurrent by visual inspection only. So example 1, check stability of given truss. DSI is equal to -1, is less than 0, so structure is unstable. Then DSI is greater than 2, unstable because of all reactions are parallel. DSI is equal to 0, unstable because of all reactions are concurrent. DSI is equal to 0, unstable by visual inspection. Rectangular panel of truss makes truss unstable. Then there are another examples. Then deficient truss. So deficient truss, M is equal to 2j minus 3, that is the perfect truss. M is equal to 2j minus 3 perfect truss, that is M is the number of members, J are the number of joints. M less than 2j minus 3, then deficient truss or unstable truss. M less than, members are less than 2j minus 3, deficient truss, unstable truss, and M is greater than 2j minus 3, it will be redundant truss. M is equal to less greater than 2j minus 3, it is redundant truss. So here kinematic indeterminacy and degree of freedom, sum of all independent displacement of all joints at a structure is called kinematic indeterminacy or degree of freedom of structure. For visualization only, for rigid structure it will be stone, inextensible reinforcing bar, extensible bar of rubber. So that will be kinematic indeterminacy. Then if members are extensible, then kinematic indeterminacy will be 7C based on this example. Then this will be second example. Rotation of member at joint of truss is not considered as kinematic indeterminacy because member of truss remains straight. Kinematic indeterminacy. Then types of releases. So first is the bending release, then real structure, and here as usual structure, ideal structure and real structure. This will be ideal structure, this will be real structure. So types of release are bending release, shear release, axial release. So axial release will be this type, shear release will be this type, and bending release will be this type, this type. There are 2D and 3D. Then elastic curve, difference between elastic curve and deflected shape. So here deflected shape, here elastic curve. All elastic curves are deflected shape, but all deflected shape are not elastic curve. Listen, all elastic curves, these are elastic curve, are deflected shape, but all deflected shapes are not a elastic curve, because elastic shape are curved one and deflected shape are straight moving, no curve is there. So how to draw elastic curve? How to draw? This is the elastic curve. How to draw? There are a number of steps. First step, by visual inspection. Step 2, by satisfying compatibility conditions. Step 3, by making BMD and elastic curve consistent. So in all coming example, all members are assumed to be axially inextensible, so statically determinate beams. So bending moment will be like this. Example 2, example, statically indeterminate beams. Now BMD for frames. How to draw the bending moment diagram for frames? So step 1, select reference face. Step 2, write bending moment at any section by considering moment producing compression on reference face as positive. Step 3, positive bending moment is plotted on reference face side and negative bending moment on opposite reference face. So for that, first you need to draw free body. Every example, whenever you are solving example, first draw FBD, consider it free from all external forces, calculate their support reactions, and then analyze the frame. So if you want to study this example, you must first learn or first listen or first watch that video during how to analyze step by step procedure of analyzing statically determinate trusses, that I have explained in audio video lecture for engineering mechanics first year engineering students. So that lecture you first study and then go study this lecture. Then these are the basic concepts. Now in the second unit we will see stability of beams and frames, or they are statically determined or indeterminate. That will be we will see in the next. So till then, goodbye, and first you watch the video carefully, you learn it, and best of luck for your GATE 2021 exam and other competitive exam also. This lectures will be helpful. So thank you.